Hello once more. We're still on the topic transformation. Last lesson we did one type of transformation which was called translation. We learned some new things. We learned about the idea of column vector, which you can use to move an object on the Cartesian plane or object point, meaning by moving left or right on the horizontal axis, whether it's negative or positive, up or down on the y-axis also. As well as an alternative method was using the formula vector plus object equal the image. So we're still using some concepts, right? But the type of transformation that we'll be doing today is reflection. Reflection. All right, let's try and see maths in real life. In our everyday experience, you might have heard about the concept. I hear a person using the word reflection. For example, in science class, through the years, you might hear them talk about light and reflection, or how our eyes work in our natural environment. If you're standing beside a well-polished, clean car, you might see your reflection in the car, on the floors in your house after cleaning it, or most commonly, the mirrors in your bathroom or in your living bedroom. Mirrors give us a reflection or image of ourselves or other objects. It acts as a line to enter into another realm. To us, sometimes we're looking in the mirror, it seems like our image is in another world, trapped inside of another world, like in the movies, right? So the idea of mirrors and mirror line, right? So some of the reasoning from real world understanding can be transferred in this lesson for you to understand the questions. But as usual, I like to tell you the importance of prior knowledge or key concepts. Know your words or your concepts before, because notes is very important. So concepts such as object, we'll still be using the concept object. So the object is the shape basically on a Cartesian plane. It can be a rectangle, triangle, trapezium, any shape, right? Any form of polygons at this level. Object point is just the coordinates or the corners, the vertex of the shape. So the x and y value. So from the object, we're trying to create images. So image or image point is the new shape that is formed from the object. Another concept is mirror line or axis of reflection line. Mirror line or axis of reflection line. Now these lines are basically graphs. You were doing them earlier when we were graphing linear graphs. So you're going to do a combination of join linear graphs along with to move the object or to create the image. Another concept is the origin. Remember that the origin on the Cartesian plane is the point 0, 0, center. And finally, the concept is symmetrical. Symmetrical. We made mention of this concept when we're doing measurement. When you fold a shape and the line that create two equal halves, symmetric. We made mention of it when we're doing quadratic parabolas, right? The vertex point, axis of symmetry, right? So in reflection, the object and the image can be equal or will be equal different from the mirror line. As we go through the activity, you will see what we call the mirror line. Okay? But first and foremost, let's define the concept reflection. So basically, we know that's a form of transformation. So one definition or one explanation is that there's no one definition for any concept. A reflection is a transformation that creates a mirror image of an object on the opposite side of a line. So you're going to draw linear lines. So what they are saying, for example, when you create an object on the Cartesian plane, we have the observation. The object on the reflection will not slide like translation. It will flip on the opposite side of the mirror line. So in this case, or in this instance, the mirror line here will be the y-axis. So it's like when you're looking in the mirror. So the mirror line here, this y-axis now is pretending to be the mirror. And when you're looking in the mirror, it's like you're inside the mirror. But most time when you're looking, all the time when you're looking in the mirror, you realize you're looking back at yourself. So that's what happens in reflection in mathematics. So the object will flip, which becomes the image. So that's one key property. The object will flip. But observe, the size of the object does not change. Size of the length of the sides, angles, those are properties you must observe. That doesn't change in reflection. The size of the length of the side, the angles does not change. They remain the same. Okay? So it's a transformation that creates a mirror image. Okay? So that's one thing to understand. Some of the things that you're going to learn today. So different types of reflection. One type of reflection we'll go through is reflection through the y-axis, just like how to show the example above. So the object will reflect through the y-axis on the opposite side of the y-axis. Now there are rules. I'm saying there's no one way of doing maths. So one school of thought you might see in your text, or one principle of getting the image points. So not most often times they give us the object points to plot, and then you must create your image. So one school of thought to create the image is that the x coordinate that is given, you should multiply it by -1, and the y coordinate will remain the same, and you use this method to get the image point for each point that is given, or each vertex. Or I'll show you also an alternate method. We can just count the unit space or distance from the mirror line. Another type of reflection we'll go through is reflection through the y-axis. So for example, the object is up here and the image will fall down here. So it's reflecting through the y-axis. School of thought, one method. The x coordinate remains the same. And to get the y coordinate, now all the y coordinate that was given is multiplied by -1, something like the reverse of this one. Reflection in the line x equal b. We did this already when we were doing linear graphs. X equal b means it's just a number on the x-axis. So when you are graphing x equals 7 and you draw a line through +7, that's what this is saying. Or x equal -3, that's the same thing. So when I say x equal b, it's just a number. You're going to run a linear graph through a number on the x-axis, and then you're going to reflect the object through that. Reflection in the line y equals c, right? And reflection in the line y equal x. Rule that you might see in your textbook. X coordinate becomes the y, and the y coordinate becomes the x. What they are saying, when they give us the object point, we just switch the coordinates and then we get the point for the image. And finally, reflection in the line y equal -x. So these linear graphs, I gave them to draw earlier. So we have to recall and look back. So one rule or one method of getting the point for the image. Both the x coordinate and the y coordinate is given, we multiply it by -1, then we switch them, and then we get, then that's the point for the image. Okay? So let's go through them one by one. All right? So let's reflect. Let's look at a question. All right. So draw the triangle A 2, 1, B 4, 1, C 2, 5. So we're going to plot these. So these represent the corners of the triangle, the vertices. And then we're going to reflect it through the y-axis, the x-axis, x equal b, y equal c. Right? Okay? Okay, let's go. So let's plot the point. Firstly, the question says draw the triangle. So we're going to draw the triangle using the point. So first point is for A is 2, 1. So 2 on the x-axis, 1. So that's the first object point, which is A. Then the second point is 4, 1. So 4 on the x-axis to 1. And that's object point for B. So always label your points, your coordinate. And finally C, 2 on the x-axis to 5 on the y-axis. And that's the object point for C, the vertex. Now we can create our triangle, right, using our straight edge. So we're creating our triangle, which now forms our object. Alright, so we have just created our object from what is given. Okay, so the first question says, A said reflect it through the x-axis, hence this object is going to end up on this side because it's going to reflect through the y-axis. This is the y-axis, so this here will be acting as a mirror line, so it'll be on the opposite side. So remember, the first procedure, there's a rule given. So the x coordinate is multiplied by -1, so you can do that to catch the image point, and the y coordinate remains the same. So you use back the y coordinate, but you multiply the x coordinate that is given by -1. That is one method. But I'm going to show you the alternative method of counting. So you can use this method of catching the points for the image. But look at this method also. For A, the space from the mirror line is 2 unit space in the same line. So we can, because what you learn in reflection is that the point on the image point will be the same distance from the mirror line on both opposite sides. So since it's 2 space from the mirror line, I'm going to count 2 space in the same line. 1, 2, hence A prime will fall right here. How many space B is from the object line? 1 unit, 2 unit, 3 unit, 4 unit. So I go over the other side, opposite. 1 unit, 2 unit, 3 unit, 4 unit. So B prime will fall right here. Point C, how many space from the mirror line? 2 space. So I'm just showing an alternative method instead of using the rule, but you can use rule. So it's good to know both methods. So this is 1 unit, 2 unit from the mirror line. So we need 1 unit, 2 unit. That means C prime will fall right here. And now we can create our image reflecting through the y-axis. Oh, sorry there. And that's our image right here. And you observe the length of the sides remain the same, so that's one property of reflection. The angles remain the same, another property. All right, so you observe it flips. So that's how you look when you're looking in the mirror. So we have just reflected the object through the y-axis. Now B said we're going to reflect it through the x-axis. So the rule that might be in your text, again, let's reiterate the rule. The x coordinate remains the same. So if you want to catch the image point, you leave the x coordinate and multiply the y coordinate by -1, the opposite of flipping it through the y-axis. Okay, so this is one rule of using to catch the points for the image. However, I'm going to show you another alternative method also. So again, using space, unit space, object point A here. So we're doing B now, we're reflecting through the x-axis. So this is the x-axis. So this is now the mirror line, or the axis of reflection line. So since as A point A is 1 space, so that means A prime prime, because this is A prime, so this is a second image. We're reflecting another image. So A prime prime, because since the second, this is A prime, the first prime, will fall here. So A prime prime, double prime, so you put 2 strokes. How far is B from the axis or the mirror line? It's 1 space, so we move 1 space. That means the point should be here. So this would be B prime prime. How far is C from the mirror line? 1 space, 2 space, 3 space, 4 space, 5 space. So I need to count 5 space going this way, opposite direction. 1, 2 space, 3 space, 4 space, 5 space. So this is C prime prime. Now we can create our image, second image from the object. So this is image 2, which is reflection through the x-axis. As simple as that. So remember, you can use the rule that is given, or you can simply just count the spaces. All right, C say reflect the object through x equal 5. So we did this already. So what you're asking for is a line x equal 5, which is positive 5. So we just find positive 5 on the x-axis and create our mirror line through it. Just a suitable distance. And that's it. And now we learn that we always name our graph x equal 5. So that's it. So now we need to reflect the object through this mirror line that is created here. Okay, so using the same procedure, we can just count the space. So how far is point B from the mirror line? 1 space. So we just move 1 space. So this would be B. Since we are creating a third object, so it would be B prime prime prime, third object. How far is A from the mirror line? 1 space, 2 space, 3 space. So the same, 1 space, 2 space, 3 space. So A prime 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 will fall here. How far is C from the mirror line here? 1 space, 2 space, 3 space. Because a reflection, when you're looking in the mirror, you're the same distance from the mirror. Your image is the same distance from the mirror line inside the mirror. So 1 space, 2 space, 3 space. 1, 2, 3. And now we create our third image. So this is C prime prime prime. Connecting our points to create our triangle because they want our triangle image. And that's our third image right there. And finally, for this question, we're going to reflect through y equal 5. So that means we're going to have to find 5 on the y-axis, because y equal positive 5. So we learned this already. We just find positive 5 and draw our linear graph. Right? So the line is going to be drawn through positive 5. And we name our line y equal 5. And now we need to reflect the object. Now this point here C is exactly on the mirror line. So there is no space. So that means that C prime 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 will fall exactly the same place. C prime 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 4 times because the fourth image that's been created. Now how far is point A from the mirror line? 1 space, 2 space, 3 space, 4 unit space. So 1 unit space, 2 unit space, 3 unit space, 4 unit space. That means A prime 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 will form there. How far is B? Same 4 space. So 1 unit space, 2 unit 3, 4 unit space. And then we connect our points. And there we have our fourth image that has just been reflected. So we have just learned 4 methods of reflection. We said we're going to do 6. So for this first video, we'll do the 4. So we reflected through the y-axis, the x-axis, x equal a number and y equal a number. Right? So there are 2 methods or more methods. We can use matrix, but I'm working through 2 methods now. So we can use the rule that I gave you, or we can just count the space. Okay, we'll finish up the final 2, reflection in the line y equal x and y equal negative x, in another video. Thank you.